Now, the application of a uniform field, one of it is Millikan's all drop experiment. So what is Millikan's all drop experiment about? In your syllabus, they actually remove the experiment from your A2, because in A2 you were supposed to learn the objective lah, but in AS you learn it like a magic trick. That means Millikan was like doing a magic trick. That means he used all droplets and he suspended it in air, mid-air. That means, you know, like levitating someone, like floating in mid-air. So he was actually levitating an all droplet. Okay. Now in A2 you were supposed to learn that the purpose was to find out the charge on the all droplet, and from there they found the elementary charge lah. But in AS right now you just learn it like a magic trick. So how did he perform this magic trick? How did he make an all droplet float in mid-air? Okay, so this is what he did. He sprayed all droplets between two parallel plates. That means I show you. So let's say there are two parallel metal plates, and he sprayed all droplets. You know how he sprayed the all droplets? You know, like a perfume spray. When you press a perfume bottle, the nozzle, the perfume comes out in droplets, right? So similarly, all droplets will come out. Okay, so he sprayed in between. Now, because these all droplets are not the same size, they will have different weight. Do you understand? And not only do they have different weight, they are also charged, and they have different charge. So why are they charged, these all droplets? Now, the easiest way to charge the all droplet is just by spraying it out of the nozzle, because the moment you spray the oil out of the nozzle, when the oil is traveling through the nozzle, it will actually have friction with the nozzle, and depending on the material you use for the nozzle, you can either make the oil gain electrons or lose electrons to the nozzle. So that means it will either gain electrons, become negatively charged, or it will lose electrons and become positively charged. Alright, so both also can. Okay, so the question could be talking about positively charged all droplets or negatively charged all droplets. Both also can. But if you want to charge it another way, there's another way which they use X-rays. So they direct a beam of X-rays onto the oil as it falls. It will also cause the all droplets to lose electrons, because X-rays are ionizing radiation. So that can also cause it to be charged. Understand now? So when these all droplets are charged, before you apply an electric field, it will start to fall because of the weight. So let's focus on one of these all droplets. Okay, let's look at this. And because it has a weight downwards, it will fall, right? But we want it to stop falling and float in mid-air. That means we must apply a force to balance the weight. So what force should we apply? An electric force to balance the weight. And if you want it to stop falling, the electric force must be upwards. No matter whether your all droplet is positive or negatively charged, you must make the electric force upwards. Why? The weight is always downwards. There's no such thing as a weight acting upwards. The weight is always acting downwards. So if you want it to balance, that means not fall anymore, your electric force has to be upwards. Do you understand? So let's say the all droplet is negatively charged. So how will you connect your two plates to a power supply in order to apply an upwards force, which is the electric force? So negatively charged particle, if you want to apply an electric force upwards, so the top plate must be positive or negative to attract it? Must be positive. So this side is positive, and then the bottom will be connected to a negative. So that this plate now positive and this plate negative. So now can you see the electric force will be upwards to balance it? Yes, right now. But you also remember there are also cases where they will use a positively charged all droplet. So let's say this is positively charged all droplet. So when you connect the electric field, connect the plates to generate the electric field. So which plate has to be positive now? Top or bottom? Because you want, once again, you remember the weight is always downwards, so the electric force has to be upwards. So in order to generate electric force upwards, which plate has to be positive? Bottom or top?
Bottom.
Bottom. So this bottom plate will be positive, top plate is negative, then the electric force is outwards, right now. That means this one you connect negative, this is positive. Understand? So this is how you will set it up. Okay? Now the equation, whenever they give you this type of question, is also very straightforward. Since we are talking about a magic trick, that means we are talking about floating in mid-air. So the equation is the weight downwards must be equals to the electric force upwards. They must be the same. So you start off with this important equation. But how much you have to break down this equation depends on how much information is given to you. For example, if they gave you field strength, but they didn't give you force, then you can change the force to EQ. Remember, electric force is EQ? And similarly, the weight you can change to mg. But if you are required to break it down further, then the E here, which is electric field strength, can change to V over D, right? And the M here, which is mass, you can change it to density times volume. Agree? But be careful, this V here is PD, this V here is volume. Do not cancel the two. Okay. And then if worst come to worst, they didn't even give you volume, they give you radius, you can also change the volume to 4 over 3 pi r cubed, which is the volume of a sphere. Okay, this is rare lah, but it could happen. Do you understand? So, but most importantly, you need this equation first. How much you have to break it down on the left or right depends on how much information is given. Do you understand? Alright, so the equation, please remember, for Millikan's all-drop experiment. So how do you know it's Millikan's all-drop experiment? They will talk about a particle suspended in mid-air. And this particle cannot be very small. That means they cannot suspend, let's say, a proton or an electron or a nucleus, because that one, the weight is too small. Do you understand? If the weight is too small, then the electric force required to balance is also going to be very small. So then the field strength, you have to generate a very, very, very weak electric field, which is very hard. Understand? So usually it is an all droplet. Not proton, not electron, not a nucleus, not an ion. It has to be an all droplet, because the all droplet is much bigger. Do you understand? But not that big lah. How big is the all droplet? Imagine you take your perfume and you spray, then all the tiny droplets will fly out in the air. Those are the size that we are talking about. Okay, which is much bigger than the electron right now, or proton, or a nucleus right now. That's what we're talking about. Okay, now we're going to talk about the significance of this experiment. So why did Millikan do this experiment? Was he trying to do a magic trick, trying to levitate an all droplet between two plates, right? Trying to show that something can float in mid-air. Actually, his objective was not that. His objective was to find out the charge of the all droplets. Alright, so you will notice that because different all droplets have different sizes and also different charges, so he repeated the experiment multiple times, in fact so many times, and he got different values of charge. Then he noticed a trend. Now all the values of charge that he got were whole number multiples of 1.6 times 10 to the power negative 19 coulomb. So sometimes you will get 1.6, sometimes you get 3.2, sometimes you will get 4.8, sometimes you will get 5.4. Wait, let me just write nicely. Oops. Negative 19, and then sometimes you get 5.4. So what does it mean, right? So he noticed that these were all values that show him that this is the minimum, and all other values that he got were actually just whole number multiples of this value. Example, this is like 2 times of this value, this is like 3 times, 4 times of what? Of this basic value. Do you understand? So therefore he concluded that the minimum value for charge has to be 1.6 times 10 to the power negative 19 coulomb, which is this, or if they don't exist in this value, they will exist in whole number multiples of this value. So that is what he called as quantization of charge. So quantization of charge means charge exists as one value of this, or it must be whole number multiples of this value. Do you understand that? Okay, So that is how, at that time, they thought the smallest charge possible was this. But is it true? Is the smallest charge possible this? The answer is no. You know why? Because later on, when you learn in your, what do you call it, your A2, not A2, you know, AS nuclear physics, right? You will learn about subparticles called hadrons, or you will learn about leptons and all those, right? And then you will find that they will have, they can have charges smaller than this. Those are called subparticles lah. For example, if you look at a proton or a neutron, you will learn that you can break it down to smaller parts. Okay, so and these smaller parts which you're going to learn have fractions of this charge. Not exactly this charge, but fractions of this charge. And these are called quarks. So quarks have fraction of this charge. But at this time when the scientist, this Millikan did this experiment, he found this to be the smallest. Understand? So, but of course, as time goes on, you get to discover new things, and that's how they discovered that there are smaller charges than this. But it still remains true in the sense that whatever we see in real life would be this small. Would be this the smallest and multiples of this, because the subparticles like quarks and all those, they don't really exist by themselves. They group together and to form a charge of this. So that's what we see. Understand? But if we purposely split it up, then only we can see the smaller charges. Okay. So this is supposed to be in your old A2 syllabus, but they removed it also. But in the recent past year, in paper 2, they started to ask about quantization, even though it's no longer in the syllabus. So I need to tell you a little bit, so at least you understand. So what is the definition of quantization of charge? It means that charge must exist as a certain minimum value or whole number multiples of this minimum value. That is quantization. Okay?